Welcome, my name is Michael Wickerson, and I am back online making tutorials that are specific to the ghpython node. And what I've done here is I've basically gone in and I've dealt with the scripting fundamentals, the utility components, and the scripting with geometry and looking at vector components. And right off the bat, you may notice that these are incredibly similar to the work that's happening on parametriccamp with Jose Luis Garcia. I love this work. I'm following it. I am learning C# programming to the specifics of what's happening in Rhino Common. However, I'm looking at the amount of views he's getting, and I'm looking at his followers, and I'm one of them. And I'm literally nose above water learning C#. And at times I've tried to put it to my own sessions, but I find the ghpython node is something that is more readable and accessible to the students I'm teaching my art school. So what I've taken is the opportunity to go in to Rhino development, use the guides, and try and move back towards Rhino Common whenever necessary, but finding a better way of navigating through Rhino and Python and learning how to translate all of Jose Luis Garcia's C# scripts, which are not incredibly difficult in any sense of the word, into Python. So this is really borrowing from that intellectual material of Jose Luis Garcia. I think it pays tribute to their hard work, and it certainly advances the people interested in the private groups that I've been hosting on Facebook on ghpython and the ghpython remote node. I hope I can continue to translate as close as I can to Rhino Common and learn how to script better in Python, not only because I'm interested in it, but also I know Python's used in Blender, and I want to begin teaching that and dealing with Python use within Blender as well next semester. But that said, looking into these scripts and starting off the first one, I wanted to give an overview of what's here. I'm not going to cover it in full detail, but the basic rules are simple. How to go into the math node and bring in a Python component. How to typeset the Python component and set its list access. How to name your scripts. So this one's been named, if we take a look in here, to ghpython script. And then how to output and make your outputs work. So very simply, following through those tutorials, I've almost followed to a T what has happened in Jose Luis C#. Now this one you can actually extend over because there's no geometry really being created off the start. And what I'd like to show is that you can get in, and he initially made these wonderful assorted scripts. Hello message console, a number output, sum, square root, and a multiplication. But the only difference with these scripts is they are not in C. You can notice from the Python symbol that these scripts have been translated by me in the simplest case from what was being written in C#. What is the bare essentials to what you need to write? And this one, you can see it even runs with a semicolon, which is not necessary in Python, but it doesn't foil the script. So Grasshopper is incredibly smart. So I'm just going to take all this and hit test. You'll see it still runs and everything's working fine. So make that look a little more, and I'm using the template of what importing things and then using the same format of algorithms that Jose Luis Garcia uses for C# just to make this work as, and of course I can't use C#, I have to use my hashtag to bring out these scripts so they actually run. So it's a simple, quick conversion. You're going to see that print becomes a smaller letter instead of a large print symbol. The maths have to import differently with not a capital M and not a capital S. And I think that's basically it. Or actually capital S on the square root. So this is what continues. So what I've done is gone through and done the utility components. And I've written them in the Python. You can see how simple they are. I stayed right in the same format as Jose Luis Garcia. You can jump in, you can open the script, see how I've typeset it, and see what's essential for running the script. A lot of these earlier samples are nothing to solve and nothing difficult. The addition, subtraction, multiplication, and division. Of course, you can have access to these scripts. You won't have to follow along with any video. It's all provided, and here they are. So a couple of little changes in here. I think it's so subtle, just the changing of using rhinoscriptsyntax and using math. You actually don't need any of this text in here, and you can start to erase all this and see how you can minimize these scripts, put them down to the bare essentials. And let's just see if it still runs, and it does, and we're fine. So there's a power, there's a square root, and there's actually this one should technically be absolute value. And here's a little tiny subtlety that I had was I was having trouble in the script making it work with absolute function. I couldn't find it from math abs. I actually had to use math f abs because as I type in, what you can do is get into this .NET framework. So result, I'll update it here, equals math dot. You can see here, I don't have any absolute. So what am I going to do? So what I did was I jumped in there and I found this little function in math abs, and it seems to have worked. Tab it in, find out what it needs, and it just needs one float to run. And there you go, you're into running. So subtle little changes that, of course, Jose Luis Garcia isn't going to do because it doesn't have this, he's focusing on C#, and this is the Python application. So as this continues, I followed through exactly what he did. I did bring in some string length concatenation and string characters, and there are subtle little differences you have to get into. So if I jump in here as Python away from the C#, I have to play with, I can't just do S length, I have to do something different. I use the function length, which is coming out of Rhino, not out of the Rhino script, but working in Python. I think there's a subtlety here of what I went into concatenation. No, it was pretty basically the same. And maybe the string characters, I had to get in and do a little appended, play around with the range a little differently than what Jose Luis was using in C#. I had to write that through at a range with the append method instead, so that would run. So there's little tiny changes. It might be worth taking a look at for people really interested in getting basic understanding of ghpython nodes. This is really what you follow. And then right here, it's very similar to the C#, but let's take a look at the series component and see what's happening here. Once again, I had to script it a little different from the C# and deal with the for loop within range, staying with the same format of hashtagging and commenting out your algorithms to inputs. Let's go down here. That's the series. Let's go into the range and let's see how that differs. The range node here from the series, you have to play a little bit around with working with an interval as an input. It still works with dot T1 minus dot T2 and then dividing by the numbers within the count, or the step within the count. And that's a nice little system that's not too hard. So it's great practice to learn C# and then try and pull it back into Python. It's much harder to take Python and move it over to C#. So that's why I'm providing this, this breakdown and series of this. When you're done that, those are the basic utility components with that up and getting it started. And then what I did was I ran this to do the same type of things with the scripting fundamentals and focus on creating points, deconstructing points, creating vectors, making a 2-point vector, construct 1 point, construct a point. Those are all borrowed by this constructing point, constructing vectors. And then you're creating a plane from that. All of these are right along lines with going in here and saying what would be to construct a plane, what would it ask for? So it's asking for the same things over here, the origin, 2 vectors, origin, 2 vectors. So that's pretty simple, and you can get into the scripts and see how they differ, and I might do that in the last one. But really, 3 scripts that I'm sharing are to start are very simple. 1, 2, and 3. This is exactly what I just showed, but it's the application of those with some hidden wires over to some very interesting components that Jose Luis had written in C#, and now I'm converting them over to Python, or actually bringing them back down to Python in my mind, kind of dumbing them down to shape for myself. Otherwise, I wouldn't be able to follow it too much. This will become more and more difficult for me as I try and learn more and more in C# and getting it the script type sensitive to everything that has to happen. This one's obviously running up to those initial ones. This one's running up here. These vectors are all running up hidden line. So that's why I brought over the scripting with geometry section here. And I might spend a little time covering a little bit of this. What's exciting about when you work in geometries is you can start to pull out the geometries of what you're looking at. I'm just going to shrink this down a little bit, make this one a little bigger. Let's take a look at it. So constructing a point follows the same template. And I wanted to show what Jose Luis Garcia had done. But in Python, you have to go in the Rhino syntax still, and you have to write that from the Rhino script library, in a sense, and you can use the same dot notation. And once your mind starts to shift to this, it really is kind of a mind-blown session. rs dot create, and what do I want to create? You can see how simple this would translate into creating vectors, creating planes, creating cross products, or maybe not creating cross product, just creating a certain type of vector. We'll see how that goes. And as you do that, say I had point, you can tab over and then hit this, and it'll show you an example of what you have to bring in. Point. And so nice and easy to start, but it gets you behind the scenes and a little more back end on what you're interested in doing. The deconstruct component is really what blows me away in the point of learning this, and it's the same example of not even having to write an algorithm, and certainly using the dot notation to find the XYZ to locate XYZ. Very nice examples. These do not have to be in Python. They can be in C#, and they're so close to scripted. But you're going to see the difference as you continue. So creating a vector, same thing. Let's go in. Keep in mind these are Python nodes. So when I click on here and go here, you see these are all Python nodes that solve, but they don't have their names, so it's nice to use that same pink box to do that. Let's take a look at creating vector. Almost exactly like the point, Rhino script syntax, create vector, and then find your attributes where you have to put it, your parameters. Then we have two vectors going to vector 2 point, and this is where you see this Rhino script. So Rhino Common operator overloads that can start treating vectors and points with the same operands as like dealing in numbers and floats, which I think is just outstanding, or possibly even string concatenation. So pretty fantastic stuff. The scripts are so simple. All I've done is convert them from C# over into Python. Here's the point, here are the two vectors, which you saw earlier, and here's the plane created with almost the same simplicity. It's almost when you begin seeing that you want to go into here and create a plane, construct a plane, what's the difference between pulling that node in than just creating the plane over here in a ghpython node? So it's cleaning up your scripts, making them run faster, optimizing, and finding a point for this. And once again, most of this script, unlike C, you can just get out. You can see how simple these scripts really are. So you can get rid of that one. And then the final exercise, which I usually do earlier, is this line looks like a line component, but it's actually a Python node. And that Python node has 2 points, and it's scripted exactly like line, Rhino script, add line, and put it in. And the biggest thing about this that you have to think about, let's take a look before we go to point on curve. Actually, I think what I'm going to do is add. I'm going to add a little bit of a point to this because I know I have an output point as well. If I'm lucky, point to point is in the point output. I'll just have to run the script again. There you go, the point's coming out. What's happening is you go into here and you take a look and you're like, well, what if I had a line and I dotted it and wanted to make it, and I wanted to find out if there was a point at, or if there was a line. Let's say if we go back to something simpler. And I'm like, well, how do I know add line's the word to use? That's why you're jumping into here. That's why you're going down to Rhino Python. That's why you're scrolling down the lines in Python. And then you see right here, there's the line ID, there's the Rhino script syntax, add line, and you need a line, and you need another line to run. So you're getting into the habit of going into these guides, finding what you can do in Rhino Common, then going to Rhino Python, all the other things you can look at. You can go into APIs if you want, and take Rhino Common and start dealing with Rhino script syntax or Grasshopper for Rhino, or you can do the Python with Rhino 3DM files if you want to write there. There's some samples to look at and follow. My goal is to go hard into only working with C#, but like I said, my following that's interested in what I'm doing is constantly asking for ghpython nodes, so I thought I would do this for everyone. And you will get more and more accustomed to flowing through here and knowing exactly what you have to type in for anything that's in use in your statements. And you will actually get the iterations of recursion happening in your scripts and have more and more control. Parametriccamp and ControlMad seem to be the two places that I love watching videos from right now, and I thank their teams for pulling it together. I hope I'm honoring them through the work that I'm doing, even though it's very basic. Point on line is a pretty interesting thing that you're actually dealing with that function. So you're going back in, you're taking a line, which is being inputted, I'm dotting it, finding out all the things that can do with that line and looking through. If you can't find it here, what I don't like is you can't scroll with your scroll key. You might be able to if you hit shift. No, you have to kind of jump and move this. It's a little jumpy. Maybe I have to adjust my user interface so that doesn't do that. So instead of coaxing through here and trying to find it in different ways of making it, I'm finding myself finally going into Rhino development and sourcing everything out to what I can find. So that's done. So that's what applies to these last scripts. And here's where I am. And I'm going to keep going with Rhino geometries. We're going to get into NURBS curves. We're going to get into lofting. We're going to get into surfaces. It's going to be really fun. So we're going to take a look here. We need a vector, and you can find a vector length. Once again, looking at the script in Rhino script syntax and using Python, it's going to be a little different. And this is where I think Jose Luis does a great job of showing you the power and simplicity of not working in how you normally would write a script using the math library, but you can actually use what's happening in Rhino Common and grab that vector and just grab the length method to that. Pretty amazing to see what's happening here. And think about it, there's nothing being used here, so I could technically efface No, I'll need the math if I want to run the first part. But I think I can just run it with the math import only, and we'll take that, and it should work fine, and there you go. But all you need are these 2 lines of code along with that one library, and you're able to find the vector length. And of course, there's nodes and vanilla nodes and ribbon nodes to do that, but you may as well find a way to do this shortcut. Setting vector length, same thing. There's all this, which I've actually got it up and running. I'm not using C, I'm using Python to get this up and running. And I think the only error there is might have cropped out my N there on new. Just caught that. But this top script will work if you write it in this way. I just had removed the C format, and then you've had to change over a couple of things when dealing with different things. And I've actually tested and used a little bit of outputs because I was having trouble with this being in Python an actual vector. And I have to wonder why I'm back to using the C notation here. So I'm actually going to take these out and see if that isn't an issue. I should be able to still run it, and it still runs fine. So I left a couple of comments. I find that very interesting in Python ignores them. It still runs, but it doesn't mind having them. So pretty interesting. So you can always comment these out, these ones down here under the Rhino Common algorithm to get the top one moving as the manual. And that might be interesting to see if that works for you as well. And let's just say OK. Let's go down here to unitizing vectors. Similarly, nothing being used here unless the math here. There is a Rhino script, so I'll have to leave Rhino script for the top part of the algorithm. And like I said, these files I'll have available. You can go in, you can try out either one, but look at the simplicity of .NET frameworks. Just go in and have the vector, unitize it, and then output that. How simple can this be? Scripting in Python never looks so simple. And then the last 3, they get a little more complicated and show once again the power of Rhino Common. This one's great because now you have a script that can be run through all of these rhinoscriptsyntax. And I don't think I'm using math. I can get rid of all these comments again up top. But you can script this and you can use that overload that we talked about before, that operators can work on things like points, like vectors, and your script gets incredibly simple to look at. So you don't need any of this. You only need these 2 lines for this thing to run. Pretty amazing. Now the last 2 scripts that I'm going to show is the vector tween, because it's a custom node that Jose Luis Garcia made and showed how to use it. And he's literally put it in here using the same Rhino Common notation that works. So very simple, and all I've done is, like I said, make all these work in Python as opposed to C#. Not rocket science what I'm doing, but I am enjoying the challenge, and I know it's going to get more and more challenging as I try to find Rhino script and Rhino Common that will work in Python compared to what's happening in C#. My end goal is to do C# solely, but like I said, so many people like working in Python, and it's easier to teach this than teach something else. So I've located the cross and rhinoscriptsyntax. And obviously there's a vector cross product here that I can make work, and then I can actually throw in a little bit of logic here, whether you want to have the assignment or have the equals value. I think Jose Luis covers this. And you have to set this to true and change it to a capital or a function in Python, and there we go. You can unitize that and run that one in. Just keep in mind that in Python, your ifs are not going to have the squiggly brackets. You're going to be using the common, the colon, and indentations where it really matter as you get farther into this. So I didn't mention that too much in the series and range component, but indentation and if and loops, you're going to have to follow a little closer. So that's it. Those are the 3 files that are available. They produce these interesting geometries. What I do like, and I didn't show an example of it here, as I take this and it moves between those 2 vectors, it's got this crazy, wonderful logical ability to move outside of the range of those 2 vectors as a tween sample. So I can move outside from 0 to 1 to reparameterize parameter t and actually move it on each area, which is allowing an area of contemplation of predictability. So I will leave that as those are the charts. This one defaulted for some reason to point. What did I do? There's a syntax error, probably because I changed something. I did. I typed in this little L to show the dot. It didn't fall through. It's up and running again. Everything should be up and running. I'm going to save that file with the update. And now I'll put these 3 files off on a GitHub so you can have access to them. They are not C#, they are in Python. I've done the conversion over for you, and you can continue on at your leisure if you want to with this beautiful advanced development series in Grasshopper, but you can also see how it applies directly into Python and rhinoscript for those that actually want to do Rhino Python instead of Rhino Common and C#. Neil, thanks very much for watching. 20 minutes of your time, and I will keep going with this. Best thing ever is that I've managed to teach Rhino, Grasshopper, and a bit of Python programming in creating user objects, and even some C# in one semester course to people novices coming to this at an art design school. Thanks again for watching.